Hi, my name is Theodora.
My name is Jessie.
And my name is Samantha.
We're from Group 5. Today we're going to learn about gallium. Always heard about oxygen, hydrogen, carbon, which is very common in our daily life. So why not? Now we learn about gallium, which is a very unique element in the periodic table that we seldomly heard. Sound interesting, isn't it? Now, let's us go and learn it. Gallium is in the group 13 and its atomic number is 31. It is discovered by Paul Emile Leacock de Boisbourn in 1875.
Now I will be talking about gallium's physical properties. So gallium is a silvery white metal and it has a shiny and smooth surface. At a room temperature, it appears in solid form. So gallium can melt in our hand because its melting point is just above our room temperature, which is around 29.76 degrees Celsius. Meanwhile, the average human's hand temperature is about 32 degrees Celsius. So this heat transfer will cause the solid silvery metal to melt into a liquid puddle, creating a fascinating science demonstration that is relatively safe for brief handling, although sometimes it can cause stain in our hand. Other than that, gallium is soft enough that we can cut it with just a knife. Now I will be talking about the physical properties of gallium. So gallium has low melting point of 29.76 degrees Celsius and it has high boiling point of 2400 degrees Celsius. In dry air, gallium is mostly stable, so it won't react easily. But when in moist air, gallium will react with oxygen to form a protective oxide layer on its surface. When gallium is burned in air or pure oxygen, it will form a white oxide called gallium trioxide.
This is gallium's electron configuration. Gallium's atomic number, which is 31, has the electron configuration of Ar, 3d10, 4s2, and 4p1. And these are the steps on how to find gallium's electron configuration. Next, I will be presenting about gallium's chemical bonds. First of all, gallium forms unusual bonds and has strong covalent bonds that could form diatomic gallium-2 dimers in its solid state. As you can see, this is an example of gallium-2 dimers. Beyond the dimers, gallium also forms metallic bonding with electric delocalization that contributes to its low melting point. Gallium's metallic bonding is unique because it forms alpha gallium, which consists of covalently bonded atom pairs, which is one dimer. These are the following examples, like gallium nitride and gallium arsenide.
Gallium has similar structure to silicon and is useful as silicon substitute for electronic industry. Gallium are used in semiconductors such as LEDs, lasers, smartphones, Wi-Fi, and high-efficiency power chargers. Gallium radioactive forms are used in cancer imaging and therapy, while gallium nitride are used in bone metabolism disorders. Gallium is used in high-efficiency CIGS for solar cells and as a dopant in silicon cells. Gallium also used to make alloys with other metals in transistors, light emitting diodes, and even in our microwave. Do you guys know that Japan, China, United States, and Slovakia are the countries that rich in gallium? They refine high purity gallium from low purity primary materials.
Other things that you should know about gallium is that it is a corrosive chemical. When coming in contact with gallium, it can severely irritate and burn the skin and eyes, possibly leading to eye damage. In addition, breathing in gallium can also irritate the nose and throat, causing coughing and wheezing. Lastly, it can also cause damage to the liver and kidneys. So, in conclusion, gallium must always be handled with care.
Galliums can be found in certain foods, but in a very small amount. For example, like cucumber, red beetroot, yellow zucchini, and also romaine lettuce. So these foods they contain gallium that is naturally get from the soil. So it must be safe to be eaten.